Today we're going to talk about how to find all the parts of a hyperbola. So I have my equation of a hyperbola here. Now you'll notice the x is not complete and neither is the y. We just have this constant here, but we need a constant for our x and our y. So we're going to have to complete the square. So I'll do that now. We have x squared minus 10x minus, in order to complete the square, this coefficient has to be a 1. That means I have to factor out the 4. So if I take a 4 out, 4 divided by 4 is 1. So it's just y squared. If I take a 4 out of 24, 24 divided by 4 is a negative 6 because it's a negative 4. So we have minus 6y. And then when I complete the square, this constant has to be over here. So I'll just add it over. I get 15 on that side. Now I can complete the square. So I have b over 2. It's going to be negative 10 over 2, which is negative 5. And then I have to square that, which gives me 25. Then I do the same for the y's here. And I'll square this. There we go. Then I put my blanks in for my squares. So I get x squared minus 10x plus 25 minus 4 times y squared minus 6y plus 9 equals 15. But with this 15 I have to add the 25 as well. And then this needs to be distributed. So I take negative 4 times 9, which is a negative 36. So I subtract it over here. Then I can simplify this, so I get x minus 5 squared. That should be a minus 4 times y minus 3 squared. And if you put all that in your calculator, or do it in your head preferably, you get 4. Now, you'll notice this obviously is a hyperbola, but you can also tell because we have a minus sign right here. Okay, the goal is to always put the positive variable in front. So that's why I left the x squared in front here, and then put the minus, the negative one, in the back. So then I have x minus the 4 of all this. That way I can see right away that this is a hyperbola because of the subtraction sign in the middle. With a hyperbola, we always want it to be equal to 1, which means I'm going to have to divide by 4 now. If I divide all of this by 4, we get x minus 5, that whole thing squared, over 4, minus y minus 3 squared over 1, because 4 divided by 4 is 1, and that's equal to 1. So this is my equation now. From this, I can figure out everything I need. So looking here, the transverse axis for a hyperbola is always the direction of the positive variable. So since x is out front, because it's positive, that's why I always put it out front, it's going to be the first one, which should be positive all the time. So my transverse axis is horizontal. So I have a horizontal transverse axis. That means that the x's will change when we find the vertices. So x will change for the vertices and the foci. Also, by looking at our equation, a squared is always the bigger number, whether it's on this one, which is not the transverse axis, or if it's on this component. So a squared is going to be 4. Let me scoot this up a little bit. So a squared will be 4, which means a has to be plus or minus 2. B squared will be 1, so b is plus or minus 1. And again, a is for vertices, so we'll have to add that to the x's because that's what changes. Let me scoot over this way. Here we go. There you go. Alright, in order to get the foci though, I need to know c. Our relationship we use for a hyperbola is that c squared equals a squared plus b squared. So I plug that in, c squared is going to be 4 plus 1, so c squared is 5. So c is plus or minus the square root of 5, which is 2.4 I think, 2.2. Alright, now my center is going to be at 5, 3, because it's always what's opposite of right here, which is in parentheses. Now my vertices, I always use A for the vertices. So this is use for vertices. I said earlier that X is what's going to change for the vertices, and that's because we have a horizontal transverse axis. So that means I have to take 5 plus 2, which gives me 7, and 5 minus 2, which gives me 3. This is my X's here, and this right here was the A's that I got. So these are going to be the X coordinate of my vertices. So then my vertices, again the X changes, so that's 7, 3, because the Y's don't change, but the X's do. So those are my vertices. And then my foci, again, the foci is also on the transverse axis, so the X's are going to change for that as well. So I have 5 plus 2.2, which is 7.2, and 5 minus 2.2, which is 2.8. Again, these are the X's that from my center, and this is C for the foci over here. So then my foci are at 7.2, 3, because again the Y's don't change, and 2.8, 3. Now if I graph this, I have a coordinate plane here. My center is at 5, 3. I'll go over 5, up 3, so I'll be right about here. My vertices, I found the coordinate points already. However, if I hadn't done that, all I'm going to do is add and subtract 2 and add and subtract 1. Since I have a horizontal transverse axis, I have to add and subtract the X's. So I'll go over 2, we'll call that, and then over 2 this way. And then the B goes up 1, the other one goes up 1. So this makes my box. From that box I can draw my asymptotes, which always go through the center, corner to corner. There's my asymptotes. My foci, again, I know the points, but if I didn't, I would just use C, which is 2.2. So from the center I'd go over 2, and then some, so there's one focus. And then over here, so there's another focus. Knowing that the focus is always inside a parabola, this has to open this way. Plus, we also know this because we have a horizontal transverse axis, so that means I open along the x-axis, or away from the y's. That's what you could think of this minus sign as. I go away from the y-axis. Y-axis runs up and down, so I'm going to go away from it by going left and right. And then from here we have to find our asymptotes as well. So your asymptotes are always lines. That's what these lines are right here. If you think of a line, your slope of a line is always y over x. In this case, my y holds the b and the a for the x. So that means my asymptote is going to be y equals plus or minus b over a. So that would be 1 over 2, because again y has the b's, and my x is where the a squareds lie, and a is 2. So that's 1 over 2. And then I just use my center here, x minus 5, and then plus 3. My center right here. And those are your asymptotes. And that's how we can draw the graph and get all the pieces we need for a hyperbola.